Hey everybody, I want to talk to you about inverse distribution functions, which I've mentioned very briefly before, but I want to talk a little bit more in depth about them because they're super important in our next topic, which is confidence intervals. So let me share up a little intro screen and we'll start talking about it. So what an inverse distribution function is, if you think about what you usually do with like a CDF function, or in Sheets in Excel, the .dist function, what you do in that case is you give it a statistic value and it gives you out an area or probability. Well, you can go the other direction, and that's what the inverse functions do. You can give it an area or probability and it will give you the corresponding statistic value. This turns out to be super important, and we will see why in a little bit when we, in a future video, I think. We'll do a couple examples at the end here. So basically, if you have a data value or a statistic and you want to find the area, it's CDF in your calculator, so like normal CDF, Poisson CDF, chi-square CDF, F CDF, all those things. Or in Excel or Sheets, it's the .dist function, so like normal.dist or exponential.dist or whatever. On the other hand, if you know what area you're shooting for, or the percentile that you're shooting for, which is really the same thing. I hope you're okay with that. Like if I say the 30th percentile, that's the same thing as saying 30% of the area is to the left of that number. So if I know my area is 0.3 or that I want the 30th percentile, those are the same thing. And I want to find the statistic value that goes with that. Well, your calculator has a function called inverse norm, INV norm. It only does normal. Some of your calculators will have inverse T as well, but it won't have like inverse F or inverse chi-square or any of that stuff that is in Excel and Sheets. And then Excel and Sheets have the .inv function for most continuous probability distributions. I'm not sure I know all of them, but all the ones that we wanted, they'll have. It doesn't have any of the discrete ones, so no binomial, no Poisson, none of that, but it does have the inverse functions for normal, and as we'll see today, or not today, but like in another video, T CDF, or the T distributions, and it also has them for, I believe, chi-square F, and there was another one I checked, exponential, I think. No, it doesn't have exponential, whatever. It's got a bunch of them. It's got the ones we need. We're going to use normal and T pretty much, and not really much of the other ones. All right, so let me, I've got a little diagram here that might help. So here's the idea. You basically have two things that you could be looking for. You could be looking for area or probability and be starting with a statistic value or data value. Or you could be starting with an area or probability and want the statistic value that goes with it. If you're starting with data or statistic value, that's when, and you're trying to find area, that's when you use CDF or .dist, right? So that's this direction. If you want to go the other direction where you're starting with area or probability and you want to know the statistic value that goes with that, that's INV norm or INVT if it's a T distribution, or just the .inv function in Excel or Sheets, which I'll show you in just a second. So it's like a big circle. And if you remember your algebra, this is essentially the same diagram you draw with inverse functions in algebra, right? I hope you remember this, but if you have some function that takes x to y, the inverse function just takes the y's back to the x's, right? That's the idea, and that's why it's called that. It's not obvious just from thinking about it. That's the case, but when you draw this picture, I hope it's pretty clear that they are inverse functions of each other. All right, so I want to do this. I want to find the 80th percentile in this distribution and 10/6. So I'm going to start by drawing a picture, like always. So in 10/6 looks like this. It's a normal distribution that I have overshot as always. There we go. This mean is 10 here, and the standard deviation is 6. This is, and I don't really need to label this N10/6, but that's what this is. I want to find the 80th percentile. So what that means is I want the value. So I want the X value that has 80% of the distribution to the left of it and 20% to the right. So this thing, I want that number, right? Where this is 0.8 over here and this is 0.2. That's what it means to find the 80th percentile. I'm looking for the thing that has 80% of the area to the left and 20 to the right. So what I want to do, I'm going to use inverse norm in the calculator, and I'll also go ahead and do this in Sheets just to show you how it works. So let me share up the calculator real quick. Calculator. So what I'm going to do is I'm going to go to inverse norm. So that is this second distributions. So the third one is there is INV norm. And I want to put in the area to the left. Now, in your calculator, you may or may not have this left, center, right stuff. I think the really new ones do, and the older calculators don't. I wish the emulator kind of didn't have it because most of my students don't usually have this. It's like 10% do or something like that. But anyway, I'm just going to leave it on left. So I'm not gonna use this just because most people don't have this. So area is, I'm looking for the area to the left. So the area to the left of the number that I am looking for is 80%, right? Let's just briefly go back there, right? See, 80% of the area is to the left of the thing that I'm looking for. Share the calculator. There we go. So 0.8, you have to put in 0.8. If you put in 80, it won't like that. It's got to be a number between 0 and 1. The mean was 10 and the standard deviation was 6. And so I'm just going to go ahead and paste that in. INV norm, 0.8, 10, 6 left. So if you don't see that screen, I think pretty much everybody sees that screen at this point, but if you have an old calculator, like more than 5 or 6 years old, there's a good chance that you might just have to type this in, right? You find inverse norm in the same spot, INV norm, in distributions, second bars. And then you just type in 0.8, 10, 6, right? Area, mean, standard deviation, and it won't give you this. Right, so just 0.8, 10, 6, close parentheses, hit enter, and it'll give you this number. That means that that question mark that I had was 15.05, let's say. So if I go back here, that means question mark here. Let's erase that. Is 15.05. Gives me 80% of the area to the left of, or so 80% of the area is to the left of 15.05 and correspondingly 20% of the area is to the right. We would say that the 15.05 is the 80th percentile of this distribution. There you go. Let's see how this works in sheets. I believe I have one open here. I do, good. So equals norm dot inv or norm inv, right? So same, those are the same thing. And it's X is the area. So 0.8, mean, standard deviation, same result, right? So it works very much the same as the inverse norm in the calculator does. Great, let's see another one. Okay, so here is the way we're actually going to be using this function most of the time. I want to find the values that capture the middle 95% of this distribution, N01. This is also called the standard normal distribution. I will explain why in just a minute, but for right now, I just want to I want to find these values. So what I'm going to do is I'm going to draw this. So this is N01, 0. And I want to capture the middle 95% of the data. So something like this. And so I've got 0.95 in the middle here. Let's go ahead and shade that blue. Right, so that's 95% of this distribution. It's the middle 95%. And I want to know what are these numbers. Now, one thing I should point out is that these numbers are symmetrical, right? They're the same distance on either side of the mean. So if I find one of them, I don't really need to find the other one. It's just the positive, right? If this is -2, then this is +2. And you might notice that the empirical rule suggests that this should be -2 and +2, right? Empirical rule says 95% of the data is between, is 2 standard deviations, or is within 2 standard deviations. That's not actually true. It's close, but it's not actually right. So let's find what the values actually are by using inverse norm. So let me share up the calculator. Oh, actually, before I do that, let's do this. So before I do that, I need to know how much area is to the left of the thing that I am looking for, right? So I want to know how much area is in here. It's not 5% because it's 5% total between these two. What I want is half of that because half is going to be on each side. So this is actually 2.5%, 0.25 here and also in here. So if I'm looking for just one number, right? So if I'm looking for, say, this number right here, the area I'm going to put into the calculator is 0.025. If I'm looking for this one over here, so this is 2.5% and 95%, I put in 97.5%, right? So 0.975. I can find either one, doesn't make any difference. I'll just go ahead and find the one on the left first by using inverse norm. So I'm going to go to the same spot. So distributions, inverse norm. Area is 0.025, so 2.5% with a mean of 0 and a standard deviation of 1. And again, we're going left here. That gives me negative 1.9599, which I'm going to round to 1.96. Right, so negative 1.96. Now, consequently, that means that the positive one is 1.96, right? I don't really need to find it. I'll go ahead and find it this time just to prove to you that that is correct. So inverse norm, 0.975. Same thing with positive, right? So let's go back to a whiteboard here. So I've got, clear off a little bit of space. Change color. All right, so this is negative 1.96, and this is 1.96. Now, the reason that this is called the standard normal distribution is historically what would happen. So before calculators and computers were good, what everybody did was use tables. Use tables that captured a certain number of standard deviations worth of area. So you had to convert everything into this distribution right here, N01. That's the one that everybody converted everything into. So it was called the standard normal distribution. And it's the one that makes the most sense because this 1.96 and negative 1.96 is the number of standard deviations that I have to go away from the mean in order to capture a certain amount of area. I'll let you think about that. So I'll let you just pause the video and think about that. But that's really what you're finding here is the number of standard, by using this distribution, is the number of standard deviations away from the mean required to capture a certain amount of area, which by the way, is precisely the thing that we're gonna want. So let's see how we can use that in the next question. So here is going to be a really common type of question. So I want to find all the values, or find the values that capture the middle 95% of this distribution, N5, 12, 107. Now, I can do exactly the same thing I just did. I absolutely could use the calculator to just inverse norm in the calculator to find this, no problem at all. However, I know from over here that if I go 1.96 standard deviations to the left and right of the mean, that will give me what I want. So I don't even need an inverse function, an inverse distribution function to do this. All I need is this number that I've already found for N01 that I can then translate into N5, 12, 107. By the way, this isn't just a random normal distribution. This is the distribution of SAT scores, right? If you're taking the math section, this is the distribution that the scores will follow. So if I want to find the middle 95% of this distribution, I can just go 1.96 standard deviations to the left and right of 512, and that will give me the boundaries, right? So what I can do is I can do this, 512 plus 1.96 times 107, right? So I've gone 1.96 standard deviations to the right of 512. And I can also do the same thing going to the left. So 512 minus 1.96 times 107. And I can go 1.96 standard deviations to the left of 512. So let's go ahead and calculate those numbers. So I don't even need an inverse distribution for my to make this work out. Although they're relatively easy to use, you could just use the inverse distribution function. It's totally fine. But this use turns out to be pretty important, as we'll see when we're making confidence intervals in a video or two from now. So let's go to the calculator and do this. All right, so we're going to have, and I'll show you, by the way, I'll show you a shortcut that some people don't know about. 512 minus 1.96 times 107. 302.28. Great, we'll write that down in a second. The thing I want to show you first, though, is this. The calculation I want to do now is the same thing, but with plus instead of minus. So I could retype the whole thing, no problem. It doesn't take, it's not like it, takes an hour to retype it. But I can also do this. If I hit enter on that, and then just mouse over or arrow key over, change that to plus, you can retype it. So if you hit enter on a calculation that you have done, it will put the calculation up again, and then you can just edit it however you want. And so if you're just changing one thing, it's really quick actually. So it's a little quicker to do that. So the boundaries here are 302.28 and 721.72. 2.28, 721.72. All right, see if I can remember those. So this is 30, no, I wrote them backwards here. 302.28, 721.72. So that means if I was looking at this distribution, where the center here is 512, then the left and right boundaries of the middle 95%. Oh my God. All right, that's unreadably bad. Let's try it again. 302. All right, great. 0.28 to 721.72. We've got 95% of the data in the middle, so 0.95 is in here. Like that. Now, I'll go ahead and use the, let's go use the normal.dis, or excuse me, the normal.in function in Sheets to see how we could do the exact same thing. So if we go to Sheets, so I could do equals norm.inv of, okay, so the left boundary had 2.5% of the area to the left of it, with a mean of 512 and a standard deviation of 107. 302.28, exactly like we saw before. And I could do equals norm.inv of 97.5% of the area, 0.975 to the area to the left, the mean of 512 and a standard deviation of 7. And it gave us the same things, right? So 302.28, 721.72. Great. You can do it either way. This whole recognition of the sort of easier way, right? The understanding this is going to turn out to be super, super useful and important for us. This is essential. For those of you who maybe had stats before, this is basically a confidence interval. Like I just made a confidence interval, and I'll show you how we're going to sort of build on that and what it all means in a future video. But that's the basic idea. So your inverse function or your inverse distribution functions will give you the statistic value that goes with a specific percentile or area. And what we want is we're going to know the area, and we'll see why when we get to confidence intervals. And we're going to want to find the relevant statistic value. So that last bit of what we were doing, we're like finding the 95% or whatever percent we want, right? I hope it's clear that we can do the middle 80%. Middle 20% or the middle 74% or whatever percentage we want. Then we would want inverse norm or the .inv function, the norm.inv function in Excel or Sheets. And I think that's all I really want to say about inverse distribution functions. They're very useful, and this is how we're going to use them. So I'm going to go ahead and stop my video right here, and I will see you guys in the next video.